in figure 6.42, which means this figure, QR by QS is equal to QT by PR, QT by PR, and also angle 1 is equal to angle 2. This angle and this angle are equal. Show that triangle PQS is similar to triangle TQR. Okay, let me draw the figure here. This is TQR, and then we have a line here, and this is P, and this is S, and then these two are joint. P and R are joint. And this is angle 1, and this is angle 2. So what we're going to prove here in this question is we're going to prove that triangle PQS, this one, this triangle, this small triangle PQS is similar to triangle TQR, this big triangle TQR. Okay, this triangle PQR, this triangle, and the other one, the big one, this triangle PQS and TQR, these two triangles. Now here it is given that QR by QS is equal to QT by PR, and angle 1 is equal to angle 2. Now let's first use this one, the first one. Angle 1 is equal to angle 2. Angle 1 is equal to angle 2. This is our angle 1, and this is our angle 2. Now let's recall what we have already learned before. Now in a triangle, if two of its angles are equal, then the opposite sides are equal. So in this triangle, if these two angles are equal, then these two sides will be also equal. If this 5 centimeter, then this will be also 5 centimeter. So here in our question, we have in this triangle, in triangle PQR, let me draw it here. This is PQR. So in this triangle, this angle 1 and angle 2 are equal. So since these two angles are equal, now this side PQ will be also equal to PR. So that is what we're going to say here. So first let's write here to prove. To prove is triangle PQS is similar to triangle TQR. Now prove is we have in triangle PQR, angle 1 is equal to angle 2. So this is given. This implies that since these two angles are equal, PQ is equal to PR. This is since the opposite sides of equal angles are equal. So these two are opposite sides of equal angles. Opposite sides of equal angles are equal. So opposite sides of equal angle. So these are two equal angles. So since these two angles are equal, the side opposite to this and the side opposite to this are equal. That means these two sides. So here we say PQ is equal to PR. Now next is we're going to use this one. QR by QS is equal to QT by PR. So now QR by QS is equal to QT by PR. Now this is given. Now here what we can do is this PQ is equal to PR. Now PR and PQ are equal, so we can replace PR by PQ. So we're going to write here QR by QS is equal to QT by, so in place of PR we're going to replace PQ. So here you can give 1, and then here you can say using 1. What we got now is, in these two triangles, now let's go back to this two triangles. In triangle PQS and TQR, let's see what are equal. Now I'm going to draw these two triangles separately now. Now this smaller one, I'm going to draw it here like this. This is PQS, and the big one I will draw it here. This is the big one. So this is TQR. Okay, so this is the small one and this is the big one, this triangle. Now what we got is QR by QS. Okay, QR by QS. See this side and this side. So QR by QS is equal to QT by PQ. QT is this side by PQ, this side, these two sides. So this side divided by this side is equal to this side divided by this side. QT by PQ. Now so the ratio of two sides are equal now. The ratio of this sides and this sides is equal to the ratio of this side and this side. Now if these two angles are equal, then we can use side angle side. These two angles are equal because this is angle Q, this is also angle Q, same angle, this is common angle. So this Q is for this triangle also, and this angle Q is for this triangle also. Angle Q is common to both the triangle. So now angle Q is equal to angle Q. Therefore by SAS similarity, these two triangles are similar. So now here let's write plus in triangle TQR and triangle PQS. Now you can show this, you can write this one here, QR by QS is equal to QT by PQ. Now you write here shown above, and angle Q is equal to angle Q because angle Q is common to both the triangle, since common angle, therefore triangle TQR is similar to triangle PQS. This is SAS similarity. So this is the proof, hence proof. Now let's see the next question. That is question number 5. Question number 5. S and T are points on side PR and QR of triangle PQR such that angle P is equal to angle RTS. Show that triangle RPQ is similar to triangle RTS. Let's draw the figure for this. S and T are points on sides PR and QR of a triangle PQRS respectively. Okay, so let's draw a triangle here. Let's say this is P and this is Q and this is R. Now according to question, this S is a point on PR, so PR, we're going to take here S, and T is a point on QR. T is a point on QR here. Now this S and T are points on sides PR and QR of triangle PQR, which means S is on this line PR and T is on this line QR. So now let's join these 2 points, and here condition is given here such that angle P is equal to angle RTS, such that this angle and angle RTS, these two angles are equal. Now what we're going to prove is triangle RPQ is similar to triangle RTS. So you write here the proof. The proof is triangle RPQ is similar to triangle RTS. So proof is, now this is a very simple question here. We can very easily prove that these two triangles are similar using AA similarity. Now I'm going to show you how we can get AA similarity here. Now in this triangle, big triangle RPQ, we're going to take this angle, and in this small triangle RTS, we're going to take this angle. Now these two angles are equal, that means one angle each are equal as of now. Now again, if we can find out one more angles which are equal to each other, then we can say by AA similarity that the two triangles are similar. Now we already got that this angle R belongs to the big triangle, and this angle R, the same angle, also belongs to this small triangle. So now these two angles are equal, and angle R and angle R are equal. So we have two equal angles here. So now we can say that these two triangles are similar by AA similarity. So now here in triangle RPQ and triangle RTS, angle P is equal to angle RTS. This is given, and angle R of the big triangle is equal to angle R of the small triangle, since common angle. Now we have two angles equal to each other, so therefore we say that triangle RPQ is similar to triangle RTS. This is by AA similarity. By AA similarity. So this is our proof. Hence proof, or you can say hence shown. Now let's go to the next question, that is question number 6. In figure 6.43, if triangle ABE, in this figure, if triangle ABE is congruent to triangle ACD, this triangle, show that triangle ADE is similar to triangle ABC. ADE is the small triangle here, up here, and ABC is the whole triangle, this big one. Now here what we're going to prove is, triangle ADE is similar to triangle ABC. Now, so we're going to use this property, congruency, the property for this. So triangle, we have triangle ABE is congruent to triangle ACD. Now let's recall that when two triangles are congruent, then the corresponding parts are equal. So in these two triangles, the corresponding parts of is AB. The corresponding sides of AB is AC, which is AB is the longest side. AB is the longest side, and AC is the longest side of the second triangle. And BE, this BE will be equal to CD. These are corresponding parts. And AE, that is the shortest side of this first triangle, will be equal to the shortest side of the second triangle. So let's say AE is equal to, AE is the shortest side of this triangle, so the shortest side of this triangle is AD. So these two are corresponding parts of congruence triangle. This is let's say this is equation 1, and the longest side is AB. Longest side of the first triangle is AB, and the longest side of the second triangle is AC. This is CBCD. This is let's say equation 2. Now if we divide these two equations, equation 1 by 2, then we will get AE by AB. Okay, let's do something here. This one we can write AD is equal to AE. So here, for example, X is equal to Y. You can write Y is equal to X. It doesn't make any difference. So let's call this one. Question 1 is this one. Now if we divide 1 by 2, dividing 1 by 2, we get left and left, AD by AB is equal to AE by AC. Now in triangle ADE and triangle ABC. Now in these two triangles, in this triangle and this small triangle and this big triangle, angle A is equal to angle A. Angle A of the small triangle is angle A of this small triangle is equal to angle A of this big triangle, because this is a common angle. This angle belongs to both the triangle. And also AD by AB is equal to AE by AC. Now this is shown above. So now what we got is the ratio of two sides of these two triangles are equal, and the included angles are equal. So therefore by SAS similarity, these two triangles are similar. Now I'll show you here. Now we have this small triangle and this big triangle. Now AD, this is ADE, this is ADE, and this is ABC. Now what we have here is AD by AB, so this side divided by this side, so the ratio of these two sides, and AE by AC. this side AE and this side AC. The ratio of these two sides and the ratio of these two sides are equal, and the included angles are equal. So by SAS similarity, now we can say that these two triangles are similar. Therefore, by SAS similarity, triangle ADE is similar to triangle ABC. ADE is similar to triangle ABC. So hence